Okay, so I'm going to show you one of the methods you could use to balance chemical equations. If we have the equation here, mercury oxide plus chlorine gas mixes and yields mercury chloride plus oxygen gas, we need to balance this by changing the coefficients in front of these formulas. We cannot change the subscripts or the formulas because they were written as balanced formulas. So let's give this a shot by counting atoms. We're going to write how many mercury do we have here, how many oxygen, how many chlorine. I'm going to write how many mercury we have on this side of the arrow, how many chlorine, how many oxygen, because it should match. Right now I have 2 chlorine over here, and I only have 1 chlorine over here. In order to change that, I need to have 2. I could put a 2 in front of this formula, and that now means I have 2 mercury and 2 chlorine. If I look at the rest of this side, I have 2 oxygen here. How many oxygen do I have here? I only have 1, and I only have 1 mercury. If I put a 2 in front of here, I now have 2 mercury and 2 oxygen, and I still have 2 chlorine. Let's try this one. We have 2 hydrogen and 1 carbon. On this side of the arrow, we have 1 carbon and 4 hydrogen. We can't change the subscript because pure carbon can be found in a single atom at a time. Hydrogen will always be found as a diatomic, just like oxygen and chlorine over here. So we could change the coefficient in front of here, but why would we do that? We have 4 hydrogen and 1 carbon. Could I put a coefficient in front of this too? I think we could. Now I know I have 4 hydrogen total on this side and 1 carbon. And on this side of the arrow, I have 1 carbon and 4 hydrogen. When you have a coefficient, you multiply the subscript by that coefficient. Let's try the challenge problem, and then we'll be all done. This one, whenever I see a single element like this oxygen, I'm going to save it for last. I'm going to start right here. I have carbon, hydrogen, oxygen. Got my arrow. I have carbon, hydrogen, and oxygen. Well, I have 2 carbon over here. This subscript means I have these 2 carbons, so I'm going to want a 2 over here. Now I have 2 carbon. How many oxygen do I have here? Here I have 4 oxygen plus 1. Now here's the funny thing. This oxygen is always a multiple of 2. So I'm going to need an even number here. How many hydrogen? We had 6 on this side. How do I get 6 here? Oof, that's ugly. I have to put an odd number in front of this. I get 3. I don't like that. Can I double everything that I've done so far? Or at least double this hydrogen. Let's see if we can work that out. It was a good idea to do these in pencil. So let's try doubling it. 6 of these waters would mean 12 hydrogen. Better erase these oxygens. 12 hydrogen. Can I get 12 hydrogen over here? Sure, I can put a 2 in front of there. Now I have 4 carbon and 12 hydrogen. I need to get 4 carbon over here. I'm going to have to put a 4 in front of here. Now I have 4 carbon, 12 hydrogen. Now I just got to work the oxygen out. I have 4 times 2, or 8 oxygen on that, plus 6 oxygen over here, which is 14 altogether. How could I get 14 oxygen here? Well, if I put a 7 in front of that, 7 times 2, I get 14. And that is a pretty tricky one. That's how you balance equations. We're going to be doing a lot more of this, but I just thought I'd warm you guys up with this problem and see how you do on the handout.